Hello legacy students, this is Miss Marsh speaking. Today you're going to learn about how to solve absolute value equations and inequalities. You're going to want to have your notes, pen or pencil, calculator, and then if you're not listening with audio right now, which you can't hear me say, but if you're not listening without audio, you are going to be super confused, so turn that speaker up. So what do you know about absolute value? Well, basically, absolute value represents the distance from zero. So remember, when I have something in absolute value bars, basically all it's doing is it's going to make everything positive inside. So 3 equals 3 because 3 is 3 distance units away from 0, right? And negative 3 is 3 because negative 3 is also 3 units away from 0. So what this is going to do is when we're going to solve absolute value equations, we're going to have two answers because there's two different ways that we can look from 0, right? So let's think of this using a graph. So I have this equation, f of x plus 2 equals 5. So I can just graph x plus 2 in the absolute value. So if we think of our transformations, that's going to move us to the left 2, and then I'm just going to go up 1 over 1, right? Oop, that's actually a pretty straight line. I'm pretty proud of myself right here. Perfect. So notice how I have graphed my absolute value. Now, let's see, where does it equal 5? So at 5, I'm going to put a line right here. So what they're asking for us to do is figure out where does this equation equal 5? Well, it's where the two intersect, right? So right here and right there. So my two answers would be x equals negative 7, right here, right? And x equals 3. That's where the two cross. That's where x plus 2's graph crosses at 5 on the y-axis. Now, are we really going to want to use this for every single graph? There's another way to get it without the graph. So you know how we've been talking about how absolute value has two arms. One's a negative sloping arm and one's a positive sloping arm? Well, that's going to help us. Basically, we're going to have this equation, absolute value of f of 5x minus 10 plus 5 equals 45. So basically, you're going to set up two problems. We're going to set up one with a negative sloping side and one with a positive side. Okay? So, first things first, though. I noticed there's something outside the absolute value. I have this plus 5 out here, right? Gotta get rid of it. You need to have only absolute value on one side. So let's subtract 5 before we even start our problem. So I'm going to subtract 5 here. And we get 5x minus 10 equals 40. Oh, this is still an absolute value. Now, what we can do, we can take this problem and drop the absolute value. To drop them, though, you need to do two problems. So I have one like this. So that's the positive sloping side of our line. Now I need the negative sloping side. So basically, I'm just going to take the negative of that line, because that would basically be the same line, but it's sloping downwards, right? That's exactly what the absolute value equation does. So let's solve both problems. So it looks like I got to add 10. 5x equals 50. Looks like I got to divide by 5. So I'll get x equals 10, right? That's one problem. Let's do the other one. So I need to distribute this negative, because that's technically a negative 1, right? Let's distribute that in. Negative 5x plus 10 equals 40. So looks like we need to start solving. So I got to subtract 10, not divide. Holy buckets. Negative 5x equals 30. Let's divide by negative 5. And 30 divided by negative 5 is negative 6. Now, let's make sure it works in our problem, because unfortunately, sometimes it won't work. No problem of yourself, but sometimes it won't work. So let's plug in 10. So I'll get 5 times 10 minus 10 plus 5 equals 45. Well, 5 times 10 is 50, minus 10 is 40. Absolute value of 40 is just 40. And 40 plus 5 does equal 45. So that checks out. Whew. No problems there. Let's try negative 6. So I'm going to plug in negative 6 to the top here. So absolute value of 5 times negative 6 minus 10 plus 5 equals 45. Well, 5 times negative 6 is negative 30, and negative 30 minus 10 is a negative 40. Now, absolute value of a negative is a positive, so I'm actually going to get a positive 40 out of this. So 40 plus 5 is 45. Whew. That one works too. We lucked out on this one. Now, this one, we need to check for extraneous solutions. What that means, no problem of your own. Sometimes there's just an answer that just doesn't work. You did the problem right, but sometimes it just doesn't work in the problem. It's just something that happens in math. It's kind of like you get it all done and you check it and it doesn't work. And it's like math is making fun of you almost. So let's try this problem. We're going to do the same thing. We're going to do 2x plus 12 equals 4x. And I got to do the negative. So the negative of 2x plus 12 equals 4x. Okay? Let's solve. I was going to almost subtract the 12, but that won't really help me, will it? Let's subtract 2x instead, so I can get my x's on the same side. So cancels out. 12 equals 2x. Let's divide by 2. So 6 equals x. Got one of my answers. Let's check the other one. So here's another way to do this. Instead of having to distribute that negative, you're going to have to do a little bit more extra work. You can actually divide by a negative 1. Right? Because it's negative 1 times 2x plus 12. So if I divide that, it's going to cancel out. Be left with 2x plus 12 equals negative 4x. Looks like I need to subtract 2x. Kind of like what you did over here. Basically, you're going to do the same problem over. 12 equals negative 6x. Let's divide by a negative 6. And I'll get negative 2 equals x. Now, let's plug in both these problems. So let's check to see if we have an extraneous solution or not. So I got 2 times 6 plus 12 equals 4 times 6, right? Well, 2 times 6 is 12, plus 12, well, that's 24. And the absolute value of a positive 24 is 24. And 4 times 6 is 24. No extraneous on x equals 6. That's a good problem. Good answer, excuse me. Let's check negative 2. So I got 2 times negative 2 plus 12 equals 4x. Well, 2 times negative 2 is a negative 4. And negative 4 plus 12 is positive 8, right? Oh, should have been negative 2 right there. Alright, that's a positive 8 equals 4 times negative 2, which is negative 8. 8 doesn't equal negative 8. Oh no. We hit an extraneous solution. So I'm going to cross out x equals negative 2 because it doesn't work in the problem. No problem. It wasn't our fault. It was math's fault. Math made us have a wrong solution. So always check your solutions. You never know when you're going to find one that just doesn't work in the problem. Now, let's take a look at inequalities. So remember, equations look like that. So basically, inequalities look like that. It has the greater than or the less than sign. How did that change your approach to solving? Just a little bit. So here's my absolute value inequality. So it looks like I need to graph. Let's graph this line right here, or this absolute value, x minus 2. So that is basically move to the right and then up 1 over 1 for both my arms, right? So if I graph this very quickly, there we go. Now, same thing kind of what we did first time. Where is equal to 4? Or no, less than 4. So I'm going to draw it at 4. So where is my red line below or less than 4? So basically it's kind of like what we did that time when we looked at where is the f of x smaller than g of x kind of thing. Well, basically I'm asking where is the red below the blue? So if we kind of highlight it here, it looks like I'm below right here, right? I'm below the blue right there. So if we write that action actually as a problem, we would have from negative 2, it looks like I'm going greater than that. Oh, So x needs to be greater than negative 2, and it can be equal to negative 2. Oh, hold on though. Can it? Because that can't be equal to 4, so it looks like it needs to just be greater than negative 2, right? And then it looks like I can need to be less than 6. Now, if you would graph that on your number line, negative 2, 6, so I'd have open dots. They'd go in the middle, which is an and inequality, right? Because ands always win inside. So I can actually write my answer as negative 2 is less than x, which is less than 6. Because it's an and inequality. Let's try it when it's greater than. So let's do the same. I have x plus 1. Let's graph that. So that goes over negative 1, and then up 1 over 1, it looks like. Then up 1 over 1 on the same side. Now I want to know when is it greater than or equal to 3. So let's go at 3, put a line. So now let's highlight where this is greater than. So where's my V above the blue? Well, I'm above the blue right here and right here, right? So basically what we need to do is we need to write two inequalities. So it looks like my V is from negative 4 to negative infinity, right? So it looks like x needs to be less than or equal to negative 4, because we can have it equal to this time. And then it looks like I need to be greater than 2. So x is greater than or equal to 2. If you would graph this on our number line, that way and that way, which is an OR inequality. So I'll put a big OR in the middle. Now, notice how the graph, the two highlighted parts, go away from each other. That's an OR inequality because they always went away from each other on an OR inequality. Let's try an actual problem like this. So I have 4x plus 5 is greater than 13. Let's solve this problem. So I have my two inequalities. I have the inequality 4x plus 5 is greater than 13. And I also have the other inequality of 4x plus 5 is greater than 13, but it's the negative version. So basically, you're going to do the same problem like you were doing with equal signs, except we have some greater than and less thans. So let's solve. I'm going to subtract 5. Get 4x is greater than 8. Divide by 4. And I'm going to get x is greater than 2. So that's one of my answers. Let's do this one as well. So let's distribute the negative in. There we go. Looks like I got to add 5. Negative 4x is greater than 18. Divide by a negative 4. Oh, I divided by a negative. Flip that inequality sign. Don't forget about that. Then we got negative 9 halves there, right? So now let's graph what this problem is going to look like. So I have a number line right here. X is, looks like negative 9 halves would be there, and 2 would be here. Open dots, right, because we're less than or greater than. And then greater than 2 and less than negative 9 halves. So my actual answer will be an OR inequality. So big OR in the middle. Now, knowing interval notation, how can we write that? Well, we do know that I'm negative infinity to negative 9 halves, right? So we'll write that. Open bracket, right? Parenthesis, because we're open. Union with, or basically this and this. So from 2, but not including 2, to infinity. And that's the end of this video. See you later, Sabers.